Hey class, this is lesson 414, exponent laws and scientific notation. So some of the laws that we learned the last couple of days, we're going to apply it to scientific notation to make simplifying expressions in scientific notation a little bit easier. So here's a problem for you to think about. How would you divide two numbers written in scientific notation? For example, what is 2.12 times 10 to the 14th divided by 5.3 times 10 to the 6th? Write your answer in scientific notation. Well, to do that problem, notice that in both these numbers we have a base of 10. So since we have the same base, we can apply some laws, exponent laws. When you have the same base and you're dividing, you can subtract the exponents. So to get this answer, it's not too tough, and I'm going to rewrite it like this. All right, to do this, what I can do is I can just divide the 2.12 by the 5.3. So I'm going to go ahead and do that. 2.12 divided by 5.3 is equal to 0.4. And then I'm going to divide 10 to the 14th by 10 to the 6th. And 10 to the 14th divided by 10 to the 6th. To do that, all you have to do is subtract the exponents. So 14 minus 6 is 8. So our answer, the equivalent of 2.12 times 10 to the 14th divided by 5.3 times 10 to the 6th is 0.4 times 10 to the 8. But it says write it in scientific notation. This is not in scientific notation because 0.4 is not a number greater than or equal to 1 but less than 10. We need to change that. We're just going to move the decimal over one place. And that makes that 4.0. Now when we do that, we made this number bigger. When you make that number bigger, we need to make the exponent smaller by 1 because we just moved the decimal over one place. So there's our answer, 4.0 times 10 to the 7th. So I really didn't need to divide these whole great big numbers. I can use the laws of exponents to simplify that process. Let's see how that works with multiplication. So here we have 3 times 10 to the 5th. We want to multiply that by 5 times 10 to the 2nd. To do that, I'm really going to rearrange these. When you're multiplying more than one factor together, the order of the factor doesn't matter. Multiplication is commutative and associative, so we can rearrange it any way we want. And here's the way I want to rearrange it to make this multiplication easier. Now I just have to multiply 3 times 5, which is 15. And then to multiply by... So 15 times 10 to the end, since they both have a base of 10, we know that we can just add the exponents together. So we get 15 times 10 to the 7th. But if the problems are given in scientific notation, then you should really write the answer in scientific notation also. So to be in scientific notation, we need that number to be greater than or equal to 1, but less than 10. So we're going to make that number 1.5. So we made that number smaller by a factor of 10. Basically, we divided it by 10. So that means we need to multiply by 10 one more time to get that number. All right, I'm going to do a couple more problems here. So this is an interesting situation. Talk about how big our universe really is. There are about 4 times 10 to the 11th stars in our galaxy and about 10 to the 11th galaxies in the observable universe. Now we're going to use those numbers to help us with these problems. Suppose every galaxy has as many stars as ours. So every galaxy has 4 times 10 to the 11th star. And we know there's 10 to 11 galaxies. How many stars are there in the observable universe? Well, to do that, we need to multiply the number of galaxies by the number of stars in a galaxy. That's assuming the number of stars is the same as the number in every galaxy as there are in the Milky Way. So what we need to do is 4 times 10 to the 11 times 10 to the 11. Why don't you just pause here and see if you can simplify that, if you know what to do, and then check back with you. So 4 times, as long as we have the same base, we're just going to count up how many times we're multiplying by 10. and that is 22 times. So 4 times 22, 4 times 10 to the 22nd is the number of stars. Now, just stop and think about how big that number is. 10 to the 22nd is a 1 followed by 22 zeros. So it's a number, starts with 4 and has 22 zeros in it. Pretty big number. Suppose only 1 in every 1,000 stars in our universe has a planetary system. So in other words, there's planets revolving around the star, about 1 in every 1,000. How many planetary systems are there? To figure that out, we need to figure out how many times 1,000 goes into the number of stars. So this is a division problem. And to do that, I'm going to simplify it for myself here. I'm just going to do 4 times 10 to the 22nd, and I'm going to change 1,000 into scientific notation, which is 1 times 10 to the third. And then all I need to do is divide these two numbers. 4 divided by 1 is 4. And then divide these two numbers. And to do that, remember when we're dividing and we have the same base, basically we are you're able to cancel the number of times you're multiplying by 10 in the denominator from the numerator. So we're going to subtract 22 minus 3. Really what we're doing is multiplying by 10 22 times and then dividing by 10 3 times, which essentially takes away 3 of the factors of 10 from the numerator. So it's 10 to the 22 minus 3. All right? And then, at the end of it, then it says, part C says, suppose 1 in every 1,000 of those planets has at least one planet with conditions suitable for life, as we know it. In other words, a planet like planet Earth. How many such systems are there? So now, again, we need to take our last answer, which is the number of planetary systems, and divide it by 1,000, just assuming that about 1 in every 1,000 has a planet like ours that's suitable for life. So we're going to divide that by 1,000 again. And once again, I'm going to write that as a power of in scientific notation. So then all I have to do is divide 4 by 1. And to divide 10 to the 19th by 10 to the third, all I have to do is subtract the powers. So I'm at 4 times 10 to the 16th. Now, at the end of the 20th century, the world population was estimated at about 6 billion people. Compare this number to your answer in part C. In other words, we're trying to see how does the number of planets, estimated planets with life, compare to the number of people in the world, in our world. Well, 6 billion is this number, a 6 followed by 9 zeros, which in scientific notation is 6 times 10 to the 9th power. Now, comparing to that, just assuming for a moment that this is the same number, actually 6 is bigger than 4, but how many times bigger is 10 to the 16th times 10 to the 9th? Well, that's not hard to figure out, and if we want, we can just divide it. So really what we're trying to see is how many times does the number of people go into the number of planets like ours that are suitable for life. What we get is if we do 4 divided by 6, we get 0.6 repeating. And then to divide the powers of 10, we just take 16 minus 9, which is 7. And then to change that into scientific notation, we would just move the decimal over 1 place to the right. So we're making that number bigger. So 6 point, and I'm going to round it to 7, the 6 repeating. 6.7 times 10 to the, now we made this number bigger by moving the decimal over 1 place this way, so we need to make the exponent smaller by 1. So 6.7 times 10 to the 6. That many times more, well, we want to write this out to really understand it, times as many possible planets with life as people on Earth. So, so is it possible that there is life out there? It sure seems like that. All right, I'm gonna do just a couple problems on this, so we make sure you understand this when you come to class. This is a multiplication chart, so we're going to multiply this number times the number up here to get this entry here. And if you did that for these two, the shortcut would be you just multiply -4 times 2, which is -8. Then you multiply 10 to the 12 times 10 to the 6. And when you're multiplying and they have the same base, just add the exponents. All right, and then I'm gonna do one more over here to find the missing number here. This is, I think this is supposed to be a division. Sorry about that, I had the wrong chart for it. All right, should work a little bit better. All right, here we go. So the one you have, we got to multiply 2 times 4, which is 8. And then we have to add those two exponents together. Since you have the same base, 12 plus 28 is 40. All right, and then I'm just going to do one more, and that should be good. The rest we'll do in class. That's this problem right here. I want to help you find this missing number here. Now this is a division, so we want to do 4 times 10 to the 12th divided by something to get 2 times 10 to the 5th. Now if I'm working backwards, really what I want to know is how many times does 2 times 10 to the 5th go into 4 times 10 to the 12th? And so really what I need to do is 4 times 10 to the 12th divided by 2 times 10 to the 5th. And using my shortcuts, I'm going to do 4 divided by 2, which is 2. And then for division, we subtract the exponents, so we get 10 to the 7. So 2, the missing number here is going to be 2 times 10 to the 7. And we can check that quickly. We did it right. If it's true, now remember this is division. 4 divided by 2 is 2. That's good. And 10 to the 12th divided by 10 to the 7th. When you're dividing, you subtract, so 12 minus 7 is 5. So that checks. So we're good. All right, we'll do the rest in class, and I'll see you tomorrow.